Good morning, lecturer. I'm Jung Yet, the group leader. Today we are presenting our LDCW project, Disruptive Innovation Grab in Malaysia. Our team has 6 members. Lee Jing Yong will cover the poster and Christensen model. Guan Zhang will discuss social impact and critical reflection. Lim Jin Chen and Ng Jing Yang will demonstrate our C++ program live. And Andrew Lin will talk through the code structure. Let me start with our agenda. We have 4 parts today. First, part 1, our innovation lifecycle poster applying Christensen model. Second, part 2, our interactive C++ graph simulator. Third, a live demo of all 5 modules. Fourth, a summary of how both parts connect. I will now hand over to Jing Yong for part 1.
Thank you, Zheng Ye. Before Grab existed, Kuala Lumpur taxis were a crisis. Rank was among 23 countries. Overcharging was routine. Meters were not used. Passenger safety was a serious concern. No driver ID, no trip tracking, no accountability. By 2014, SPAD received 10,000 taxi complaints every year. This is a documented statistic from Razali and hence 2016. In Christensen's model, this is stage 1. The incumbent has overshot mainstream needs. Taxis were serving tourists and business travelers at premium fares. The average commuters was abandoned. In 2012, two Harvard Business School classmates, Anthony Tan and Tan Hui Ling, launched My Taxi. They had won second place in the HBS Business Plan competition with a safety-first proposal. Their mission was simple: work with taxi drivers to help them do better business. The app offered 3 things traditional taxi never had: GPS tracking, so passengers could share their ride, the driver identification display before boarding, and upfront fare estimates so passenger knew the cost in advance. This is stage 2. The entrant targets the overlooked segment, safety-conscious, budget-aware commuters. Here are all 5 stages mapped to Grab. Stage 1. The KL taxi industry overshoots 10,000 complaints per year. Stage 2. My Taxi launched in 2012 targeting abandoned commuters. Stage 3. The entrant improves GrabCar in 2014, regional expansion to Philippines, Singapore, Thailand, and GrabPay in 2016. Stage 4. Comfort the Go. The incumbent retreats to cooperate contracts and airport routes. They don't fight, they flee upmarket. Stage 5, disruption. It completes in March 2018 when Grab acquires Uber's Southeast Asian operations, a platform that started in KL serving overlooked commuters, restructured transportation across 8 countries in 6 years. Section 3 of our poster show the disruptive trajectory graph. The bottom line is the traditional taxi service quality stays flat. The rising line is Grab moving through 3 tiers: budget commuters at entry, ride safety and convenience as the differentiator, then premium fleet at the high end. This is Christensen's core visual insights. The entrance performance rise and intersects with mainstream expectation while the incumbent stays still. I will now pass to Chong Zhan. Thank you.
Thank you, Jing. My name is Gan Zhan, and right now I'm going to present about the market disruption. Stage 5, a disruption complete. Uber C acquisition that happened in March 2018. Grab acquired Uber ride-hailing and food delivery operation across 8 Southeast Asian countries. Uber received an equity stake and exited the market. Comfortable traditional taxi monopoly was displaced. The platform mediate model became the new industry standard. But disruption is not just about the market share. Let me discuss the social impact. Grab disruption had 3 major social dimensions. Firstly, safety. Before Grab, a passenger have no record their journey. After Grab, GPS tracking, driver verification, and shareable ride details become standard. In our C++ program, we show driver rating and PSV license verification, exactly this accountability feature. Second, gig employment. Grab lowered the barrier to entry. Driver no longer needed expensive taxi license. Flexible hour creates supplementary income for thousands of driver partners. Third, financial inclusion. GrabPay, launched in 2016, allowed users without a bank account to participate in digital economy, topping up with cash at convenience store. Now I need to be honest about the tension in our analysis. Christensen classic model say disruptors start with an inferior product at lower price. Things still mini-meals. They met lower quality rebar but cheaper. Incumbent didn't care because their best customer didn't want rebar. Grab did the opposite. It starts with superior safety, better transparency. A passenger who values safety would choose Grab from day one. Does this break the model? No. Christensen and Rayner later describe new market disruption. The entrant doesn't steal the incumbent's customer. It serves non-consumer people who alternative is nothing. Many Grab earlier users have stopped taking taxi entirely. We also consider Winston model. The chaos taxi crisis was what Winston called a supervening social necessity. Social need drove adoption as much as technology did. One more limitation, Christensen studied this drive and excavator manufacturing industry. Platform businesses like Grab have near zero marginal cost and network effect. The 5-stage structure still work, but the mechanism inside each stage are different. They conclude part 1. I will hand to Jung Kwan for the live demo.
Thank you, Chongzhan. For part 2, we built a Grab Super App simulator in C++. It is a console-based program with 5 modules, which is Book Grab Ride, Fare Estimator, Grab Food, View Last Booking, and About Grab Innovation. We had 11 name constants, a booking record struct, 3 arrays for drivers and vehicles, randomization, and input validation on every single user input. This module maps directly to a concept from part 1. Let me show you. Here is our main menu, 6 options, just like Grab's Super App home screen. Let me book a ride. Now I have entered a booking for 3 passengers, 10.5 kilometers, rain and peak hour both yes. The fare is 25.5 ringgit, that is 17 ringgit base fare plus 8.5 ringgit surge, a 50% multiplier for combined rain and peak. Before confirming, the program shows a booking summary, passenger name, route, vehicle type, driver, ETA, total fare. And it asks, confirm booking. Let me confirm. Here is the receipt. Look at the driver information. Rating 4.7 out of 5. Verification, PSP license. These are the accountability features that differentiated Grab from traditional taxis, now implemented in code. Now let me show you what happens if I cancel. Now confirm booking. We press no, enter. Booking cancelled. No record saved. If I go to the module 4 now, it still show the previous confirmed booking, not this cancelled one. So you may see there is no record because our struct only store confirmed rights. Now I will handle to Jingyang for the remaining modules.
Okay, thank you, Junquan. So I'm Ng Yang. Now you will see the module 4, view last booking, and how it handles the empty stage. Let me show you the module 2, fare estimator. This lets user check price without committing to a booking. So we back to the menu, press 2 to enter. enter the distance. So we enter 8 kilometer, enter. It is raining, put Y, enter. Is it peak hour? Y, enter. Then we will show 8 kilometer with full search. The estimator show base fare 14 and 60 cents. Search 7 ringgit 30 cent. Total estimate 21 ringgit 90 cent. Same calculation as module 1, but not booking is correct. This is just the pricing transparency with that traditional taxi never offer. So now let me show you the GrabFood. Click on next slide. So the module 3 represents Grab ecosystem expansion. Crystalline stage 3 where the enter at adjacent service. So back to the menu. Enter 3. Let's select the restaurant. Okay, put 1. Enter. Menu. We choose McChicken meal. Press 2. Enter. Quantity 2. Enter. Delivery distance. So we through kilometer. Enter. So now I select a McDonald's McChicken meal quality 2, 3 km delivery. The receipt show the item name with quantity. 2 times McChicken meal. Food cost 25 ringgit 80 cent. Delivery 3 ringgit. Total 28 ringgit 80 cent. So this is demonstrate how Grab extend its platform beyond ride hailing into food delivery, increasing user retention through ecosystem lock-in. So this is finally the module 5 about Grab information. This is our break between part 1 theory and part 2 code. So back to the menu, press 5. Then so the 7th session covering the KL taxi problem, crystalline model, distribution machine, dynamic pricing, and ecosystem expression. It concludes by linking each simulator module back to the theory. So now Andrew will explain how the code is structured.
Thank you, Jingyang. My name is Andrew. Let me walk you through the key technical decision. At the top of our file, 11 named constant replace all magic numbers. Base fare, rate per km, search rent peak, changing Grab's pricing deck on edit, not a search through 600 lines. Our book record short group 7 file with a has record validity flag. It's global, so modules 1 and 4 share data without complex parameter passing. 3 arrays store Malaysian drivers' names, Grab car modules, and Grab 6 modules. Randomization select as drivers, vehicle, ETA between 2 and 12 numbers, and a rating between 4 and 5. The 6 come from system time, so every run is different. Every single input is validated, scene.fields cache, non-numeric input, range check, enforce business rules. The get yes no input helper is shared across 3 modules. Following the dry principle, error message use a consistent exclamation mark prefix. Next, our gate log show add incremental commits. We start with the menu framework, add modules 1 and 2 with best fast calculation, then driver arrays, GrabFood, the shard for booking storage, error handling, and finally code police with comments and constant. Each commit represents one feature stage. The progression is logical, build the skeleton and core service, then harder and refine. 5 of the commit have extended description explaining the change. Back to Zhenyet for the summary.
Thank you, Andrew. So what did we do? In part 1, our poster applied Christensen 5 stage to Grab from KL taxi crisis to the Uber C acquisition. Our writer reported the critical depth on social impact and model limitation. In part 2, Our C++ simulator brought those concepts to life: dynamic pricing, driver verification, upfront fares, ecosystem expansion, not just described in theory, but implemented in working code. The poster and the program are two halves of one argument. Grab rise from a two-person Harvard startup in 2022 to Southeast Asia dominant super app in 2018 is a real-world case of iterative innovation. So that's all for our presentation. Thank you for watching.